All right, so I'm going to finish off some of the rules for building ontologies that I started off with in the morning. The slides now are up here. So this is ontology.buffalo.edu/biodiversity. And the slides for tomorrow are still rather in the form of notes, since tomorrow will be more reactive. That is to say, I will be reacting. So the very basic idea that I was trying to communicate is that Buffo gives you a starting point for building ontology. So the way you use Buffo in the simplest possible case is that you import Buffo into an ontology editor. You work with the domain experts to create an initial classification of the main entities in your domain. You aim, let's say, for 50 of the most commonly used terms in your domain. You arrange these terms into an ISA or subtype hierarchy as best you can, following this rule that A is going to be a subtype of B only if universally every A is a B. Now, then you'll find that you have to fill in some missing terms that people in your domain would never use, but which are important to complete the hierarchy. So I'll give you an example from the FMA. Buffo has the term site, which means roughly a cavity or a hole. For instance, the interior of this room is a site. And in anatomy, there are cavities in the body, which are called anatomical cavities in the FMA. Now, no anatomist would use anatomical cavity or anatomical spatial cavity. There are no cancers of the anatomical cavity. But the FMA needs it because it needs to link to Buffo. So the definition of an anatomical cavity is a site which is part of the normal architecture of the body, or words to that effect. That's the easiest possible case. In most cases, you won't import Buffo into your ontology editor. You will import some lower level ontology. So if you're building the infectious disease ontology for brucellosis, then you would import IDO, and you would add terms for brucellosis specific processes and brucellosis specific molecules and so forth as children of terms in IDO. In an even more complicated case, you may need to import portions of several ontologies. And then you will build your definitions by using the resources of these several ontologies. And thereby the ontology that you create will be extending downwards from multiple existing resources. Now, there are increasingly good tools for doing this sort of importing. Just a year or two ago, people didn't know how to do importing. They thought that to import into an ontology, you needed to import the whole of the external ontology, which would mean that your ontology would become gigantic very quickly. But now there is a tool called OntoFox. Actually, no, it's called OntoDog. It's Fox. OntoFox. If Fox doesn't work, try Dog. Which is designed to make it easy to import fragments of ontologies for specific purposes within other ontologies. Now, I showed you this picture earlier. So this is what happened with the cell ontology. This is a picture which shows you how the relations work. And I'm presenting this picture now because it's bringing us towards the main topic of the afternoon, which is how we deal with data about instances. So we have here an example of what is involved in a simple measurement of blood glucose. So there is a device, which is a blood glucose measuring device. There is a portion of blood which is derived from the blood inside John. So here this machine here creates a sample. The quality, which is John's blood glucose level, this is a Buffo quality, inheres in this particular portion of blood which has been extracted by the device. The device measures this quality. So it measures John's blood glucose level. This is the screen of the device. And this screen here communicates to us a measurement datum. The measurement datum is about the quality, which is John's blood glucose level. Now, the measurement datum could exist on a different screen, or it could exist in speech, or it could exist on my laptop. But as it happens, it's concretized, it's made concrete, in this particular case, by this two-dimensional pattern on this particular screen here. So we have the quality, which inheres in the screen, which is a two-dimensional pattern, which is shaped like this, 120mg/dl. And the whole thing is centered around this Buffo occurrent, which is a process. It's a OB process. OB is the ontology for biomedical investigations, which is a specific kind of measurement assay, namely a blood glucose measurement assay. Now, this is, it seems complicated. I hope it's intuitive. Most, even simple measurements are at least this complicated when you try to work out what they involve. The Buffo has all the relations that you need in order to capture this particular scenario. I don't see how you could make it simpler without simplifying. Now, does everyone understand this? Or any questions, worries, concerns?
I'm concerned about, like, if I'm trying to describe data, I don't want to go through all this.
Good. So something which I should have said is that once you've done the work of importing Buffo, or whatever else you do at the top, you should very quickly find a way in which you can disguise the fact that it's there, because none of your average users are going to want to see all of that. But unless you use it at the starting point, you'll make mistakes, I would claim. And I can document that ad nauseam. And you really, truly, you would be nauseated by the time I was finished. Now, similarly here, the reason we do this is because we're trying to build OB as a controlled vocabulary for describing what's involved in an investigation. We may want to do this for FDA purposes. They want to see exactly what was done. We may want to do it so that we can teach somebody how to do it. We may want to do it in order to check which particular experiments were indeed the same experiment, rather than just using the same words, but when we see in more detail, they actually did something different. So this kind of detail is there because reality includes all of these dimensions. But for most ordinary purposes, you probably only need this. Actually, you probably only need this here. Or probably you may only need this. So I'm not saying that people should be showing this to everybody. On the contrary, I'm a strong believer in hiding it as quickly as possible. I'm showing it to you because when I look at the Darwin core, or the OBOE, then I see a missing layers which cause problems. They cause a certain redundancy, they cause some confusions of meaning, and I'm going to try and show that tomorrow. All right? So I've just said all of this, so I don't need to say this again. Now I have a handout, which is, I'm not sure I have enough copies. Probably I don't, but anyway. I'll give half of them down each side of the room, and the people at the end can fight. So this is just to show you that Buffo is not quite as simple as I suggested this morning. There is more to it. Most of what you see on this handout has to do with spatial and temporal and spatiotemporal regions. So there are 0-dimensional, 1-dimensional, 2-dimensional, 3-dimensional spatial regions, for instance, which takes up a whole quarter of this picture. I'm going to go through not all of these terms, but some of them in the course of the rest of the afternoon. But I'm not going to try and cover everything. If people have specific questions, then they should feel free to raise those questions. But I'm giving you this handout so that you can see how things relate to what I've already said this morning. So you can see what I said this morning as the quadrant up here. And then we add temporal region, spatiotemporal region, two kinds of temporal regions. We don't actually specify what kinds of spatiotemporal regions are because there are too many. Then we have qualities, dispositions. We have material entities, which are, for instance, objects such as a molecule, or fiat object parts such as a mountain. I never finished that story, but a mountain is not an object. A mountain as we normally conceive it, as a geologist conceives it, it is an object. An object aggregate would be something like a population or a community. An immaterial entity is a cavity, a site. We talked about that. And then we have roles and we have functions. I'll talk a little bit about roles later on. And I think that's about enough.
If you were doing physics, what would heat be?
So energy is an independent continuant, and we don't make any claims of completeness here. It's likely that we will be adding another sibling term to material entity, which would cover energy. We are actually just starting to work on the ontology of physics now. And so this says Buffo 2.0. It should say Buffo 2.0 brackets draft, because this has not been ratified yet. Buffo 1.0 is, in fact, very similar. The changes are changes of detail rather than changes of radical structure. And Buffo 1.0 is what everyone is using.
Now, if you actually have, in the history of heat, when it was believed to be caloric, it was thought to be an immaterial fluid.
Yeah.
That's what made me think of when I saw the word immaterial here.
Yes.
A weightless fluid, but nonetheless it was a fluid. That kind of concept, I mean, you said immaterial entity is a space. It's a name for an absence.
Yeah. There are two kinds of immaterial, actually no, three kinds of immaterial entity in Buffo. There is sites, cavities,
okay,
which can move around in space, as when I move my head.
okay.
Then there are spatial regions which can't move around in space because they are space. And then the third kind are what we call continuant fiat boundaries. And an example of a continuant fiat boundary would be the boundary dividing the left half of this room from the right half of this room. It's not made of matter, but we can still refer to it. It still plays a certain role. If you cross it, then you enter the smoking zone, or in the old days. Yeah. People fight over things like that. Any more questions? All right, so, and now the example I just gave was a case of measuring a quality, but we also have cases where we measure a process, for instance, where we measure heartbeat. And the current work on the revision of Buffo is about how we deal with qualities of processes, like the rate at which a heart is beating. And I don't think we need to look at this because it's similar to what we had before. Well, I'll just mention one thing. So there is a quality which is a 120 beats per minute shaped pattern of the screen on the device, which is measuring the process of John's heart beating. And otherwise, everything is pretty much the same. All right. Yeah.
So how would, if you wanted to represent the fact that John's heartbeat, the heart rate is 100 beats per minute,
Yep.
how would you represent that fact using that using a relationship?
So I'll come closer. The idea that we are pursuing goes something like this. This is the first time I've ever spoken in public about this, so I have to think very carefully. This has been a long, multi-year debate between different communities. So when we're dealing with continuants, like, for instance, a blood glucose level quality, then we have the quality which can be gained or lost by the portion of blood. So the portion of blood might have a different blood glucose level at different times, or it may have 0 blood glucose level. Now, there is nothing like that within the realm of occurrence, because occurrents don't change, because they are changes. That was what we had this morning. However, if you track a heartbeat, for instance, then you can produce a chart which represents a certain pattern. And that pattern has qualities. You can see it on the chart in front of you. So the idea is to distinguish different processes according to the patterns which they generate when represented on a graph. Does that make sense? So some heartbeat processes will generate regular patterns, some will generate irregular patterns, and so we have a distinction between two kinds of processes, those which generate regular patterns, beat patterns, and those which generate irregular beat patterns.
Oh, no, it does make sense.
Yeah.
But, I'm not sure it answers my question, which is there's that quality of 120 that's inhering in the screen is inhering in that screen at a particular time. So,
yeah.
Right, there's a time dimension that I guess you left out
yeah.
for simplicity. But if you want to throw that time dimension back in and then say at this time you want to represent the fact that there in fact is this heartbeat of this value, what would that look like?
Good. So you're familiar with the epsilon delta way of defining rates, differential magnitudes in elementary calculus.
I've seen it before.
So it goes something like this. What we mean when we say that John's heartbeat is 120 beats per minute at noon is that however, so given any, I'll read it in the official epsilon delta language. Given any epsilon, we can find a region of time within which John's heartbeat, I have to be careful here. So we can only measure heartbeats over certain regions. We can't measure heartbeats at a point. That's obvious.
So to simplify the example, let's go back to the previous one, which was milligrams per deciliter of blood glucose.
Yeah.
Right? Because that you presumably don't need epsilon delta.
Yeah.
Concepts. So how would you represent that fact? That at noon he had a blood glucose.
Well, in the case of continuants, there are no real problems here. In the case of continuants, we can take a sample at noon, and then we can measure that sample. And the sample will stick around long enough for us to take the measurement.
What I'm really getting at is, if you wanted to query your medical history knowledge base to know what was John's blood glucose at noon, would you need, presumably you don't want to query what, at noon, what was the property inhering in the screen, and then you have to parse out what this, 120 characters mean. I mean, you want to record that fact directly. So I'm saying, we'll ask what properties would you use to record that fact?
So you are raising now an intriguingly deep point, which actually impacts nearly everything that we're doing when we are talking about measurement data. So when we're talking about measurement data, on the one hand, we're talking about measurement data. But on the other hand, we're doing that because we really want to talk about the qualities of the things that we're measuring. Yes?
Yes and no, right? I mean, some measurements are themselves the quality, right? I mean, like if you have a binary measurement like occurrence, something is there or isn't there at the time.
But still, I would say that when we're talking about measurement data, there are two things going on. One is the data that we're talking about, and the other is the entities which that data is data about. And I think that when I look at some of the artifacts which have been created by this community, then it's not always clear whether you're talking about the data or the things that the data is about. And I think I can show that. It is clear sometimes, but not always. I'm trying to be clear, but now you're forcing me to say what it is that I mean clearly. And I mean this. This is what it is to be clear.
So I guess, really, I've been saving up another question that I guess I'll ask
Yeah.
which is that the example that you gave of the success of this ontological approach in the biomedical community had to do with indexing and searching literature.
Yeah.
And you give example of apoptosis, and here you can see that, okay, this is it doesn't matter if that word was used. In some cases, there's a specific type of apoptosis that's occurring, and it doesn't matter what organism is occurring in, and you'll be able to find all instances of apoptosis across the literature. And so the terms in this ontology, the gene ontology, I understand, are primarily used to annotate the literature, to provide something much more useful than keyword annotation. But the data that we mostly are interested in capturing and querying is what we would, I guess, call measurement data, or an occurrence. That it's not the literature, it's the primary data itself, and it's saying this taxon, an individual of this taxon occurred in this location at this time, and it had the following phenophase, and the following measurements were taken. And I'm wondering about what aspects of the approach gene ontology is being used for in the biomedical community are going to apply to that sort of biodiversity data, and which aren't. And I was wondering.
So in your description, in order to describe the measurement phenomena that you are interested in, you use several terms which are not measurement terms. Individual, taxon, occurrence, I think there were a couple of others. So that would be the first job, to get clear about those things. Secondly, when I look at the notes which were sent around, the issues that people wanted to be discussed, it seemed that at least several people were very concerned about how they can keep track of connections between measurement data and the samples from which the measurement data derived. And in order to keep track, there are going to have to be other kinds of information which are non-measurement information. Who took the sample, what instruments were used to measure the data, where the data was stored, how the data was stored, how the data was validated, and so forth. And so all of that will be non-measurement data. It might be measurement metadata, but it's not measurement data. Is that, am I breaking through something?
That, but I mean, I'm sure do you agree that there's utility in expressing the fact that John had a blood glucose of 120 at noon, as opposed to expressing the fact the quality of the shape of 120 appeared on
oh, yes,
screen.
Good. Okay, so if it's, yes, so sorry, I'm not, yeah. Yeah, good.
Very simply, I'm wondering how would we represent this?
Good. So I am very, very sensitive about the issue when it comes to heartbeats, and so I was oversensitive about the issue when it comes to simple measurement data. So, of course, we can represent John has blood glucose level of such and such. That's trivial. For buffer, that's trivial. You don't need this to express that. You need this to express the measurement process. But the measurement process needn't take place. John would still have a blood glucose level of such and such, even if it was never measured. He would still, this may be a little bit contentious, but he would still have that blood glucose level even if no measurement devices had never been invented, and deciliters or any measurement system had ever been invented.
So I think what you're saying, though, is different than a measurement of his...
I'm trying to say what he wants to be said. So he wants the quality.
You're talking about a measurement, right?
Well,
no, he's talking about the value. And he wants the value. He wants John's quality to exist even if it's not measured.
Well, I do want that. I mean, whether I want it or not doesn't matter.
Yeah, well...
I mean, the distinction between data and metadata becomes blurred because you have a measurement event, and that has a person that takes the measurement, that has an instrument, and it has a value. And who's to say what's the data and what's the metadata? I mean, you could use the value as metadata and say find all devices that have found measurements of 120. So you did answer my question. You
Good.
raised a host of others, but
There are many questions here. I'm going to move on.